Okay, here's another one of how to solve multiple solutions. We're looking for the interval on interval um, 0 to 2 pi again. So we're finding all solutions. On the interval 0 to 2 pi. We have secant 4x over 2 or equaling 2. In order to go through this, once again, because we have our b value, the b value is greater than 1, we're going to have many solutions. Whenever b value is not equal to 1, you're going to have a lot of different solutions. So that's what you're looking for, the b value. So from here, we know secant. I don't like to keep secant like this. I like to put it in cosine because that helps me out a little bit. You can, because we like to put the inverse cosine. So I'm going to put it as 1 cosine of 4x was 2. We'll flip this around, and now we have cosine of 4x equaling 1/2. We'll go over here now, and we'll just graph that out just to see where we're talking about. So when we go over here and we take the inverse cosine, we'll have inverse cosine of 1/2 right here. Cosine is positive. Cosine is positive in the first and the second quadrant. So cosine of x, or cosine of this, just put cosine. Cosine is positive, greater than 0, in the first and the second quadrant, remember. Okay, because that's when, oops, cosine positive there. That's not the second quadrant. Hopefully you're all just sitting there going, what? Mr. Gutchuk, what are you doing? I'm sorry. That's here, because that's when x is positive. All right, right there, because cosine is x. All right, so we're looking for this. We have our ratio, which is 1 and 1. Our cosine is adjacent over hypotenuse. 1 and 2. Holy cow. All right, 1 and 2. A little crazy right here. I apologize. Okay, 1 and 2. And so what is this angle going to be? Well, this angle, well, this is going to be radical 3 again. So this is going to be pi over 3. And then this one, whoop, okay, right there, that's going to equal uh, 5 pi over 3. 5 pi over 3, I apologize. 5 pi over 3. And that's in the fourth quadrant. Fourth quadrant. So now the question is, what do we got here? Well, we have 4x then is going to equal pi over 3. Now remember, because we have greater than 1, we're going to do a coterminal plus 2 pi n. And then over here, we're going to have 4x equals 5 pi over 3 plus 2 pi n. And now we're going to find all of our different angles. Okay, so from here now, we're going to solve for x. Okay, so now we solve for x. Solve for x by dividing by 4. So when we divide by 4, this is going to equal, okay, x is going to equal pi over 12, okay, and that's going to be plus 2 pi n over 4. Then right here, divide by 4, we have 5 pi over 12, and then this right here is going to be 2 pi n over 4, okay, because once again, you're taking this, solving for x, we're going to multiply both sides by 1/4, multiply by 1/4, so that turns into x, and that turns into, distribute through, we got 12, and then we got 2 pi over 4. So now from here, we're going to find all our solutions, okay? So now we're going to find all solutions on the interval, remember? What are we talking about here? On the interval from 0 to 2 pi, because that's what they stated, all right? That's what they stated, or else it would be done. That would be done right there, okay? 2 pi. So we're going to write this out, and we're going to have different values. So we're going to have n equaling 0, we'll have n equaling 1, we'll have n equaling 2, and we'll see how far we need to go. All right, we'll just keep on going until we get to 2 pi. Now, what is 2 pi in this case? Oh, well, because we have a denominator of 12, 2 pi, where we're heading to, I would like to think about this, we're actually going up to 24 pi over 12. How did I get that? I just multiplied pi bottom by 12. So these are one and the same, but that's what I'm kind of looking for when we're doing this. So now, Taking this, looking at our ends, looking at our ends. All right, actually, look at these ends, look at these ends. I'm going to change this up, and we're going to make this into the same multiple of 12. So this is going to turn to 12. I need a 3, so it's going to turn to 6. So we have 6/12s, 6/12s, and that's going to be the same. So that should help us out. So now let's do this. So boom, 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 boom. All right, so for the first one, we're plugging 0, so we have pi divided by 12. Right here is going to be 5 pi divided by 12. We'll then plug in a 1 in here. A 1, we're going to have 7 pi divided by 12. We'll plug in a 1 here. We'll have 11 pi divided by 12. We'll now plug a 2 in here. 12, we'll have 13 pi divided by 12. We'll then put a 2 into here, 2 into there. That's going to be 12. 12 plus 5 is 17. 17 pi divided by 12. We probably need to go a little bit farther, so we'll do an n equaling 3 as well. Plug in 3 in here. 3 times 6 is 18. It's going to be 19 pi's over 12. Right here, we're going to plug in a 3 into there. That's 18. 18 plus 5 is 23. 23 pi's over 12. I feel like the count from Sesame Street. 23 pi's over 12. All right. I'm sorry. When you have that, we 23 pi over 12. Remember, we're going up to 24 pi's over 12. We can't go any farther. We are done. These are all of our solutions. We can actually see there's a pattern. Pi, 5 pi, 7 pi, 11 pi, 13 pi, 17 pi, 19 pi, and 23 pi. If you don't see those patterns, just plug it into the coterminal. And when you get to 2 pi, you stop. All right? So we stop here. Okay? Because this and this, all right, that's as far as we go in this case. All right. So these are all of our solutions. Okay? And those are the answers to this. Once again, if you have a calculator, you can take this out right now, and just to verify, we have 1, 2, 3, 4, 5, 6, 7, 8 solutions. Okay, so if you want to take out a calculator, I'll pause this right here, and I'll take out mine. So if you took out your calculator, and you have this, remember secant is 1 over cosine. You can't, there is no secant button on your calculator, so you have to go 1 over cosine of 4x. We're going to 2. I'm going to change my window right here. We're going to go down. This is still from 0 to 2 pi. This is pi over 12. I'm going to change this into negative 3. And we'll change this to 3 just because we're up to 2. And we'll graph this. And we'll see what happens here. Okay. And we see at our 1, 2, 1. So if we kind of just draw this out, we'll see that there's a little point right here. It's going to be 1, 2, 3, 4, 5, 6, 7, 8. 8 possible solutions. You can test by trace. We've done that in the past. You can also go find second calculate intersection. All right, number 5, if you want to do that as well. But all these different things, just to save time, I'm not going to do that. But we can verify we do have 8 solutions. And on our calculator, we also have 1, 2, 3, 4, 5, 6, 7, 8. 8 solutions. And we have the right answer. So I'll put a little smiley face right there. Okay, hope this helps you out. I'm going to do a couple other problems, but continue plugging away. You can do it. So good luck and God bless.